Okay, so welcome again. Good afternoon. So we're going to solve another problem now related to hypothesis testing in chapter 9. Okay, so let's start. Guys, another reminder, I would like to remind you every now and then. Guys, if you already watched the video, pause the video and try to solve the problem on your own. This is how you check your understanding on this particular problem. Okay, so before we start, what are we going to do? We have to draw the framework of the problem, and every time we read some values here, we have to put it in our framework. Okay, so let's now start reading. Suppose that in the past years, the average price per square foot for warehouses in United States has been 32.28. So that's the population mean. Then a national real estate investor wants to determine whether that figure has changed now. Okay? The investor hires a researcher who randomly samples 49 warehouses, okay, that are for sale across the United States, and finds out that the mean price per square foot is 31.67. So from that sample, the mean price is 31.67 with a standard deviation of $1.29. So in this particular case here, this standard deviation is sample standard deviation. Okay, sample standard deviation because this portion here, standard deviation, was discussed in the portion where the sampling is in. So sampling and then the standard deviation was discussed. So we can say that this standard deviation here is a sample standard deviation, and then using the significance level of significance of 0.05. So what conclusion can you reach, and what are the hypotheses? Okay, so basically what we're trying to do here is, this is the standard, okay, 32.28, and then after data gathering, the researcher found out that the mean changes to 31.67. But the question is this 31.7 significantly differs from 32.28? That's the question there. Okay, so in order to answer that question, we have to solve it using statistics. So what's the hypothesis? Step one, we have to establish the hypothesis. The null hypothesis is always the equal sign. So the null hypothesis, the mean is still equal to 32.28, and then the alternative is the 32 point not equal to 32.28. Step 2, determine the appropriate statistical test. Since the sample standard deviation is given, so we're going to use the t statistic here. Okay, that's the formula from our previous chapters. And then we have to set the alpha value. The alpha value is already given. That's 5% level of significance. And then establish the decision rule. We can establish using the z table, the t table, or we can establish using the critical value method. Okay, in this particular case, in the t table, since this is a two-tailed test, we have to divide the alpha here into 2. That is why alpha divided by 2 is 0.025. And then the degrees of freedom, that's just n minus 1. In this case, 49 minus 1, that's 48. Again, how did we come up with our t-score here? So we have to take a look at the t table. We have the 48. Do we have 48 here? We have the 48. And then what is our 0.025? 0.025 is on this column here. Yeah, so this is 2.0106. Let's check. 2.0106. Let's round off to 2.011. Okay, so, or in the distribution plot, this is our distribution plot here, two-tailed, and then the t distribution with a degrees of freedom of 48. Okay, next is we have to solve using the critical value method. So this is the critical value of the formula, and then same as usual, we have to replace the sample mean by critical xc, and then we simply plug in the values of this t here, and then that one, if you don't want to have an error, or you do not very like the algebra, so you can simply use your calculator. So let's start with the negative value, 2.011 Kasi this is the positive and negative here. So we have to solve it individually. And then the equals here, not this equals here. We have to access the equals here. The pink, alpha equals. And then we have to access the fraction. And then xc, we have to x here, alpha x. And then minus the 32.28. And then for the denominator, you have 1.29 square root of 49. And then do not press equals. We have to solve. We have to access the solve function here. We will let the calculator solve for the value of x. Shift solve the value of x. Just press equals. And then the negative is 31.91. So let's check if we have same. 31.91. And then again, if you want to solve the positive side, please just click on maximize the replay. And then just press backspace or delete. And then you shift solve again. And then just simply press equals. 32.65. 32.65. Okay, so as simple as that. So we already have the decision rule. And then we have to now to analyze the data. We have to substitute the data, the 31.67 here, the 32.28 for our population mean, and then 1.29 for our sample standard deviation divided by square root of 39, that's negative 1.31. Okay, and then we are going to plot that one, so around here, estimated around there. So take note that the value is in the rejection region, Okay, so this is the non-rejection region here, and this is the rejection region. And we can also decide using the critical value method. The 31.91, that's the lowest critical value, and then our sample mean is 31.67. So 31.67 is around here. Okay, so that's why the critical value is very important when you are in the real life, so that we cannot in the actual scenario, that is because we need not to solve the t-table. You have to look at the table. You can simply say that the critical values, in order for the sample mean to be still accepted, is within 31.91 to 32.65. Okay, since the mean of the sample here is 31.67, which is below that range, so we can say that we have to reject the we have to reject the null hypothesis stating that the mean is still equal to 32.28. So how do we conclude this one? So since the t-score negative 3.31, which is around here, is in the outside region, outside of the non-rejection region, okay, or basically is in the rejection region, and the sample mean is 31.67, which is outside the critical values of 31.9 and 32.7. Hence, we reject the null hypothesis. This implied the average price per square foot for warehouse in the United States significantly changed. Okay, so good luck and God bless.